Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cyber Security, working in Dr. S.N.S. Rajlakshmi College of Arts and Science. In today's topic, I'll go to explain about deadlock. So, in deadlock, we'll see about what is the deadlock and how deadlock will work. So, these things will be discussed in the next slides. In a multi-programming environment, several processes may complete for a finite number of resources. A process requests resource, and if the resource are not available at the time, the process enters a waiting state. Sometimes the waiting process is never again able to change state because the resource it has requested are held by other waiting process. This situation is called a deadlock. For example, a set of blocked process heat holding a resource and waiting to acquire a resource held by another process in the set. System has two disk drives, P1 and P2, each hold one disk drive and each needs another one. Another example, two train approaches each other at crossing. Both will come to full stop and neither shall start until other has gone. So these are the example. Next, a pictorial representation of a deadlock is given here. Okay, so at the same time, two resources are asking same kind of resource means on that time this deadlock will occur. System model. Resource something a process uses. It is usually limiter. The resource may be either physical resource or a logical resource. Processes need access to resource in reasonable order. Two types of resources. Preemptible resource can be taken away from a process with no ill effects. Non-preemptible resource will cause the process to fail if taken away. When do deadlocks happen? So the thing is given here when and all the deadlock will occur while you are executing the process. Process 1 holds resource A and requests resource B. Process 2 holds B and requests A. Both can be blocked with neither able to proceed. Like deadlock occurs when processors are granted exclusive access to devices or software constructs. Each deadlocked process needs a resource held by another deadlocked process. So here the picture that represents process A and process 1 and process 2 request resource A and B at the same time. So on that time deadlock will occur. So what is a deadlock? So the definition of deadlock is given here. A set of processes is deadlocked if each process is in the set is waiting for an event that only another process in the set can cause. Usually event is release of currently held resource. In deadlock, none of the process can run, release the resource, be vacant. Four conditions for deadlock is given here. Mutual exclusion. Each resource is assigned to at most one process. Hold and wait. A process holding resource can request more resources. No preemption. Previously granted resources cannot be forcible taken away. Circular wait. There must be a circular chain of two or more processes where each is waiting for a resource held by the next member of the chain. Resource allocation graph. Resource allocation modeled by directed graph. Example 1, 2, 3. Here we have given three examples. Resources are assigned to process A. Process B is requesting or waiting for resources. In example 3, process C holds T waiting for U. Process D holds U waiting for T. C and D are in deadlock. Dealing with deadlock. How can the operating system deal with deadlock? It ignores the problem altogether. Hopefully, it will never happen. It detects the deadlock and recover from it. Dynamically avoid deadlock. Careful resource allocation. Prevent deadlock. Remove at least one of the four necessary conditions. We'll explore these trade-offs. So from these things, we'll avoid deadlocks. So this lecture explained about the deadlocks and other conditions. What are all the conditions we are using in deadlock? You will understand that. Thank you.